Quadratic inequalities in two variables. So very similar to our last day where we're solving linear inequalities in two variables, quadratics is no different, except instead of drawing a line, we are drawing a quadratic function, so a parabola, and either inside that parabola or outside of that parabola. So some key elements here. Okay. First, in order to sketch this parabola, some key points you need to find, obviously, would be the x-intercepts, the y-intercept, and the vertex. Okay, x-intercepts, fairly straightforward. You're just solving this equation for x when y is equal to 0. So I'm going to factor this. We've done this so many. So my x-intercepts occur at -1 and a +3. Okay, and now I want to find my y-intercept. Is fairly straightforward because when its y-intercept is -3. So you can plot that point. And then finally we need to find the vertex. Well, to find the vertex, remember the x value of your vertex is a -b divided by 2a. So I'm going to take a -2 divided by 2 times 1. So this ends up to be a +1 is the x value of the vertex. And then we're going to find the y value by substituting 1 into the equation to find the y value, which works out to be -4. So the vertex of my graph is 1, -4. Okay, so here's some key points on my parabola sketch. So when I sketch this parabola now, I want to look at my inequality and identify, well, my inequality just says less than, so we want to draw a dotted parabola. So do a sketch the best that you can, and this needs to be dotted. Okay, so there's my parabola. Now I want to identify, okay, I need to do some kind of shading. Do I shade inside the parabola or do I shade outside the parabola to satisfy this inequality? So just like linear inequalities, we're going to do a point and again choose that test point 0, 0, unless it's actually on the line, which it is not. I'm going to substitute 0 in for y, 0 in for x, and I'm going to ask myself, is 0 less than a -3? This is the question you're asking. Okay, is 0 smaller than -3? And no, this is not true. So normally if it was true, I would shade inside, but because it's not true, I'm going to shade everything on the outside of my quadratic, or my parabola. And that solve a quadratic inequality in two variables.